Welcome to the latest demonstration video of a new kind of general-purpose data management system called Didgets. Now, a Didget, which is short for a data widget, is a special intelligent data object that forms the building blocks of this new data management platform. Because it is a platform, thousands of applications can be built on it. One application, called the browser, will be demonstrated here. But it just calls our platform API to do the real work, as any other application can do. The platform is a global distributed object store with some very powerful features. To keep this video short, I will just show a few of them. So as a quick introduction, let me first explain the problem where this thing is designed to address. As everyone knows, data is exploding all over. We have unstructured data, things like documents, photos, video. We have highly structured data, things like customer transactions or patient information or mortgage applications. And then we have a large volume of semi-structured data, things like logs, web traffic analytics, things like that. So luckily we have data managers that can handle all these different kinds of data. We have our primary systems, things like file systems that handle unstructured data, relational databases that handle the highly structured stuff, and then for the semi-structured data, we have all kinds of NoSQL solutions that have been introduced. On top of these primary systems, a number of secondary systems have been created. Things like a photo organizer, for example, might use a file system to store the actual photos, but also use a database to store the metadata associated with those photos. Now, each one of these systems forms a data silo. I mean, it generally is designed to handle just a single kind of data. The file systems only handle files. And some systems scale better than others. File systems are notorious for not scaling very well, meaning once you get a couple million files within the file system, it becomes very hard to find all of your photos or all your documents with a certain attribute on them. Now, each system has a separate API, so applications have to know how to talk to all the different APIs in order to get all of your information and connect those pieces of information. Systems generally don't talk to one another directly. So if you want to copy a file from one file system to another, an application needs to do that. Same with databases and these other solutions. Now, each container has its own login, backup, replication, security, other organizational structure associated with it. So it takes a fair amount of expertise in order to store and manage data within each one. Because our data gets fragmented and split up between all these different kinds of data managers, connectivity of all these the data within these silos becomes problematic. This might be extreme here, but illustrates kind of how systems have to connect with one another. Well, Didgets came along, and we decided to invent a new kind of data management system that can handle all the different kinds of data and do it in a very systematic and uniform way. Because of that, we had to build a hybrid system. We had to build a better file system than other file systems, a better database than other databases, basically a better way to find and use data. Now, unfortunately, what most people, when they think of hybrid, think of something cobbled together that doesn't really do either thing very well. But in our case, we wanted to build something like this, where it is a hybrid, but it does two or more things exceptionally well. Now, to do that, we had to build a very simple structure. So the digit each digit has a metadata record, has a data stream associated with it, and a set of tags that we can attach to each digit. So finding digits and manage them is very simple. So let's get right into the demo. This is what we call the browser. It's an admin tool. We use it to demonstrate the power and flexibility of our system. We've got a couple pods over here on which we've created a number of digits. I'll be demonstrating the database functions. So here we have some definitions for some tables. We've got some connectors to some external databases. But here's some tables that I've created along with some queries associated with each one. The data set I'll be showing today is Chicago crime data. So the City of Chicago publishes on their open data platform all the crimes reported over the last 19 years. So there's, as you can see, there's almost 7 million rows in this table. I've got a couple of queries that I've created against this. This is standard NoSQL kinds of stuff. We can find every row where the primary type of crime was assault and the location description of the street. Or for the south, everywhere where the block address had a south indicator within them. Or in this case, a little more extreme, the evening crimes in the spring. So where the date ends in a PM, and it starts with either a 3, 4, or 5. To show how to get all of the data, you just double click on the table and we do a select all against that. One of our nice features is we can just go up on any column header, say show me all the values, and we'll instantly show you every unique value within that column and how many rows each value have. We can chart these, so we can select a bit of them and show you in a nice little chart with a bar graph or maybe a pie chart. Give you a visual representation of that data. Or we can drill down. I want to see just the assaults, so I just double click on there and it'll show me the 430,000 crimes where the primary type is assault. And I keep drilling down. If I want to see just assaults that happened on a sidewalk, here we have 57,184 of them. And we also want to see just the ones where an arrest was made at the time of the crime. In this case, 15,580 different assaults that happened on a sidewalk when an arrest was made. If we don't like that, we can go back and go down a different path. Maybe we're looking just for sidewalk assaults in district number 6. Again, we'll let you drill down really fast and find subsets of this table very, very quickly. Well, let's say we wanted to do some analytics on this. So we want to plot various crimes over time. So I can come here and I can create a pivot table. There's 35 different crimes, and I want to pivot it by year. Because year is a value, we can either add them up or we want to just count them. And we want to do all 19 values. And so just that fast, we created a pivot table of almost 7 million values, how many crimes for each year within this table. Let's say we want to do the same thing where we're drilling down and doing just a subset. So we only want to focus on maybe crimes in community number 30. So there were only 105,000 crimes, and we want to do that same thing for pivot table on primary type across years. Count them up. And same kind of pivot table, except this time we only have the crimes that were committed within community area number 30. We can save that off as an entirely new table. We can let you drill down, do analytics, and make it very fast to see your data in a very uniform way. I'd like to mention briefly that this computer I'm running this on is an old computer that I bought back in 2011. So it's 8 years old. It has an Intel i3 processor, and it's quad core. It's got an SSD, but not very fast. It's the old SATA 3 type. So the point being that a simple $400 computer you can buy at Walmart right now could outperform this thing. This thing is so fast because of the software, not because I'm running it on some exotic hardware. I'm not connected to the cloud here, so I'm not running this in some kind of Amazon cloud cluster. This is all running on this desktop, and we give you very, very fast results. I like this data set because it is pretty good size, meaning there's no way you can load this into Microsoft Excel or other spreadsheet and do the kind of analytics that we're doing on this. Yes, you could put this in Postgres or SQL Server or MySQL and do queries against them, but they're much slower. On average, the same data set in Didgets as those other database systems is about twice as fast. And so, this new system, I'm not running on top of a database. We are the database. Didgets is the thing that's doing all these operations. We're looking for early adopters who can throw in their own data sets and try this out and see for themselves how easy it is to do analytics, how fast it is to do queries, and overall help us move this platform forward. If you don't believe me how fast this is, we'll give you the download link and you can just try it for yourself. Thank you very much.